Common problem faced by the Res Life staff here at Emory is finding staff members to work over winter break. Currently, an Excel sheet is sent out to all residential advisors where they can fill in their availability information. Then the director of Res Life, Kayla, manually sorts through everyone's availability to create the staffing schedule. The goal of our project was to automate this process. Using Google Forms, VBA, and Excel, we created macros that take in the availability information, transpose it into a solver model, and create the schedule that optimizes RA's preferred shifts. In reality, we have this model set up to accommodate 50 RAs that are interested in shifts over a 20-day winter break schedule. However, for the purposes of time in this demo, I will demonstrate on a 5-day spring or winter break with only 9 RAs. So the first thing that the user will see when using this model is the winter break form. So in this form, they will fill out their full name and then choose the residence hall that they wish to work in, which is divided into 4 different areas. Lastly, they will be able to fill in their availability information for each day, where 0 means they are unavailable, a 1 means they are available, and a 2 is their preferred shift. So once the form has been filled out, it will populate into a Google Sheet that looks like this, where we have the names of the RAs as the rows, followed by the area that they chose and their availability. However, for the purposes of our model, we want this to look a little bit different and how we can input it in the solver. So we see that we want to actually populate the data into a table that looks like this, such that we can then use it in the model. So if we hit the Populate the Data tab, we see that the form populates all of the availability information from the Google form into a format that we can use in our solver. So now looking at our solver model, we have binary decision variables for the shifts that the RAs receive, where a 1 indicates yes, they have that shift, and a 0 indicates no, they do not have that shift. In order to optimize the model, we use a fairness score highlighted in green that is the sum product of the availability information and the decision variables. We use this sum product because we want to weight the preferences that the RAs filled out in the form when making decisions for the shifts that they will receive. We also have many constraints on the structure of how RAs are assigned their shifts. So every RA that signs up is guaranteed to get at least 1 shift. So the right-hand constraint shows that the sum for each RA of all of their shifts is greater than or equal to 1. There is also a restriction that only 1 RA can be working in a particular building on a given day. So we have that the sum for each building each day is equal to 1. Additionally, the director, Kayla, will only receive a shift if there is no one else available on that day. So we have a linking constraint using the M method, where 1 minus Kayla times M is greater than or equal to the sum of the remaining RAs, ensuring that she only has those shifts when there's nobody else available. So with all of these constraints and our objective function, we are able to hit the Assign Shifts button such that we populate a schedule. And we see here that we have our binary decisions with 1s and 0s assigning the shifts. And we can confirm that Kayla has only received a shift when there was no one else available for that day. Once the solver has created the optimal decision for the schedule, we can create a final schedule output that lists all of the names and what days and where they will be working. So we hit the Form a Schedule button, and it populates all of the names for the areas in a given day.